Newton's second law of motion describes how force, mass, and acceleration interact with each other. A very large misconception that I used to have about what this equation meant is that Newton discovered it, somehow experimentally. But it's actually just the definition of force. 1 Newton is defined as how much force is required to accelerate 1 kilogram of mass at 1 meter per second squared. So how much force is required for 1 kilogram of mass to increase in speed by 1 meter per second every second. Let's see how we can work with this equation. Of course, the first thing that you'll notice is that because it's an equation, we can rearrange it to solve for any one of the variables. All right, so let's look at an example. If I have a mass of 100 kilograms that I'm pushing to the right, and it's accelerating at 0.5 meters per second squared, then how hard am I pushing it? How much force is required to move it? All right, so just intuitively, let's think about this. If I had something that was 1 kilogram moving to the right at 1 meter per second squared, then that means that obviously you're putting 1 Newton of force into it. Well, the same proportion can be applied here. What's 1/2 of 100 kilograms? 50 newtons, which is the same thing as plugging it into the equation. 100 kilograms of mass times the acceleration of 0.5 gives you 50 newtons. Now let's look at another example. Let's say that I have a pitching machine that applies 30 newtons of force to a 1 kilogram baseball for 2 seconds before shooting it out the end of the pitching machine. How fast will the baseball be moving once it exits? First, we need to find out how much this ball accelerates every second. That means that we've got to solve for acceleration, which is force divided by mass. So, if we have 30 newtons of force applied to 1 kilogram, that's 30 divided by 1, which is 30 meters per second squared. But that's not how fast the ball is moving once it exits, because we know that it's accelerating by that much for 2 seconds, which means that in the first second, its speed increases by 30 meters per second, and in the second second, it increases by that same amount. 30 times 2 is 60 meters per second.